All right, this video is going to talk about arcs and chords. So you remember the other day or yesterday we talked about a minor arc and a major arc. We're also going to talk today about a chord, okay? So first of all, let's just go over the parts of a circle again. These two you should have already known. The radius is just half of the diameter. The diameter is going fully across the circle, okay? A chord does not necessarily need to go through the center, but it does need to go from one end of the circle to the other, okay? So a chord can exist anywhere within the circle. If it just so happens to pass through the center, then it is a diameter. So a diameter is a chord. Not all chords are going to be a diameter, but a diameter is a chord. So in a circle, if a diameter is, okay, there we go. Definition of a chord. In a circle, if the diameter, circle, so diameter. If the diameter is perpendicular, remember perpendicular means it makes a right angle, to a chord. So now I'm going to draw a chord, and this chord can be anywhere, but it has to be perpendicular to this that's going up and down. So it could be here, it could be here, it could be here, it can be anywhere, okay? But it has to be perpendicular. If that is true, then it bisects the chord. So that's it, easy enough. So here it is, here's the diameter, here's a chord, it's bisected. That means that if this is 12, then this is 12, so done. In this one, it's perpendicular, I just didn't draw it. AB is 16. Well, what would happen to 16? It gets cut in half, 8 and 8, great. Next one, AB is 35. Fantastic. What is AC? Well, this means that this is 35, so this would then have to be 70. Last one, MN is 24. What is LM? That would also be 24. So easy enough, but it can't stay that easy. There does have to be one more step here. And that step is going to be using good old Pythag. So this says if DS, now please be careful because DS only travels from here to here. If DS is 14 and PR is 32, so here's PR, the whole thing is 32, and right away I'm going to say, well, wait, that's just 16 and 16. Then it's going to ask you to find DR. I don't see DR, but I can construct DR. And oh look, DR is a radius. However, it also makes a right triangle, and it makes a right triangle with legs of 14 and 16, and I'm looking for its length, and so I can just use good old Pythag. 14 squared plus 16 squared equals something squared. I don't know what that is. What is this? 196 and 256. Let me just double check. Not the best at math. I was right. Plus 196. So that equals 452. That's x squared. We are going to factor out a perfect square. I think 140. No, that doesn't work. 452. So, shockingly enough, it's not a large perfect square. It's actually root 4 times root 113. This is going to be a prime number, which is how I know that there are no other perfect squares involved. So it's just going to be 2 root 113. Okay. You do need to do a little bit of like behind the scenes math for some of these. So this wants you to find x, and this is telling you that this little piece right here is 2. Now, this is a radius of 5. In a circle, all of the radii are the same, which means that in this case, all of the radii should be 5. So if AJ should be 5. You already have 2, so this is just going to be 3. Look at that. Now here is your right triangle. I'm not even going to do math because this is a Pythagorean triple, so x is 4. Okay, and then sometimes you have a radius, but it's not in the right place, so you're just going to swing it around. So I'm just taking this and moving it like the hands on a clock. Okay, if you want to see just the triangle, I would just take out this triangle. This is 5, this is 10. Now at this point, you should stop getting ready for Pythagorean theorem because there is a triangle where the leg is just half of the hypotenuse. And so by default, this has to be a 30, 60, 90 triangle, making this side 5 root 3. And so in order to find x, you would just double that. So 2 5 roots of 3 are going to be 10 roots of 3. All right, moving on. Whatever, we're not going to do that. It's the same question as before. Okay, and then there's this other theorem. We don't need to call it theorem 10.6. It's just a rule, okay? If you have your diameters and they kind of like get cut off here at an equal distance, then that means that the chords have to be congruent, okay? This statement in math, if and only if, it's actually abbreviated like this. That kind of statement means that it works backwards as well. So if you saw this picture and you had 2 chords that were congruent, then you can say the reverse is true. Then they are equally spaced out from the center, okay? So AB is congruent to CD if and only if EG is congruent to EF. And then it also works the same backwards. So this is true if that is true. So here's an example. Because these 2 chords are the same, you are allowed to say that these 2 expressions are the same. So 7x minus 8 equals 3x. I will just move the 7 over. Who cares? It's negative. But it won't be for long when you divide by -4 and get x equals 2. They want you to find EF, so just substitute it back in. 3 2s is 6. Technically, this should also equal 6, which it does. 14 minus 8 is 6. The measure of arc TV is 121. And since these chords are congruent, then the arcs are also congruent. And so then this is 121. Same thing here. Since these parts of the chord are congruent, it kind of splits the arc in half, making this and this congruent. And so 4x equals 80 minus x, which means that 5x equals 80, which means that x equals 16. Oh, find the measures. X is 16, so 4 16s, what is that, 64? And 64. Does it want anything else? It wants CE, which is the whole thing, so this would equal 128. And that's that. So when you're doing these are pretty, like, you could probably have made the assumption that these were going to be equal, but just be careful when you're doing these. If you have to swing the radius or cut something in half or take away part of the radius, just make sure you're kind of like manipulating the problems to set them up for how you need to solve them.